Okay, let me change it up here. Let me give you another one. I'm trying to trick you. What is the degree of this polynomial? 5. It's not the first power of x you see, it's the highest power of x you see. All right? So this is your degree, which is odd, right? And the leading coefficient is not the first number you see, it is the number that's in front of the highest power of x. So the leading coefficient is -7, which is a negative number. So you're odd and negative. Make sense? Okay, so odd, negative. So here's odd, here's negative. So we look like that, don't we? So that would be your answer. What do you think? That's pretty straightforward? As long as you have the table, right? You're good to go, you think? Okay. All right. So I think I'll move on. So I want to take a look at a specific example. All right? Let's take a look at a specific example to kind of motivate how we're going to do this. Let's take a look at f of x equals x cubed minus 4x squared minus 5x. Okay, that is not a quadratic, right? That's not x squared, so it doesn't look like a parabola necessarily. Can you tell me the end behavior of this? So is it up, 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 down, down, up, down, or down, up? What is it? Down, up. So if you go back to that table and do your little thing here, here's your degree is odd, right? What's your leading coefficient? It's 1, right? So it's going to be positive. So odd and positive means you go down on the left, up on the right, right? That's what I know so far. So when I draw it, it's got to look like that. The question is about the middle part, right? So this is just to kind of get us motivated. Let's just think about this. Our graph, when we draw it, I know that the left side has to go down and the right side has to go up, doesn't it? But I don't know anything else about what's happening in here, whether or not it goes up and down and wiggles around, who knows? So what piece of information could we potentially find that would help us have a few more points to graph that would maybe aid in the x-intercepts, right? Like maybe it does cross through here, right? And so maybe, you know, like if I knew it did this, right, like went through there, then I would actually know to draw there, wouldn't I? So wouldn't finding the x-intercepts be the next, like, most natural step in trying to graph this? And that will be our second step. Now, I haven't given you the steps yet. I'm just trying to, like, motivate where we're going to get them from. So I'm going to now think about what would the x-intercepts take for this. If I wanted to find them, how would I find them? Same way we've done anything, right? Whether it be a line or whether it be a parabola, we've always set y equal to 0, haven't we? In other words, we've set this equal to 0, which is the same as just set the whole thing equal to 0 and solve, right? So let's just do that. X cubed minus 4x squared minus 5x, let's set it to 0. Now that is not a quadratic. You cannot use the quadratic formula. But we spent some time, right, on this already, learning, making sure we understand how to factor something. So can we factor the left-hand side? Start with GCF, right? GCF would be x. So we can pull an x out. That would leave us with x squared minus 4x minus 5. And then the next step would go to go in here and see if we can factor this. I actually made it so it would factor, all right? So this is where you'd have to maybe go and do that thing on the side where you're going like -5 and -4 and trying to come up with your two numbers that do that little thing. So I'm going to put a little dot dot here, which just means this might require you a little more time at this step, right? But I'm going to assume that, you know, since it's going to be on your next test, that you can actually factor that. And that would lead us to the next line, which would be this. All right? And now, what does this mean? If I've got this set up like this, what can I say?
That you have 3 points.
I have 3 X-intercepts. The first one is this one set to 0, which just gives me 0, right? The next one is this one set to 0, which just gives me X is 5 when I move things around. And then I set this one equal to 0, and that gives me X is -1, right? Y'all with me on that? Okay, so let's go back and just think about the graph again. In the back of my mind, I know it goes down then up, right? All right. But I also know something more. I know that at -1, I have an X-intercept. I know that at 0, I have an X-intercept. And I know that at 5, I have an X-intercept. So that's a little bit more information, isn't it? So let's try and think through this a little bit more now. The left side has to go down, right? So imagine that, you know, you're back in first grade and I'm asking you to connect these dots with a smooth curved shape, right? It's got to be smooth and curved, no corners, right? Can't pick up your pencil. So if I were to start at this point and start drawing it this, like to the left, I have to go down, don't I? Because this is the furthest point to the left and I know it goes down on the left side. The leading coefficient test told me that, right? So I know that from this point, it has to go down. I also know from this point on the right that it has to go up, doesn't it? The question now becomes, what's going on in here? So let me draw, and I don't recommend you put anything on your paper yet, but just tell me whether or not this makes sense. That it maybe goes up a little bit here, comes back down, comes back, and goes through like that. Wouldn't that be a nice, smooth, curved polynomial function? So what I put in green there seems okay to you? Yeah? Okay, I agree. That could be the case. But could this also happen? I come up here, and instead of actually passing through this X-intercept, I kind of like bounce off it like a wall. Okay, so like a ball would bounce off something. And then it comes down a little bit here and then comes up, and maybe it bounces off that one. And then comes back down and then crosses through and goes up. Could that be a scenario? Would I still have the same X-intercepts? Yes, I'd still have the same X-intercepts, right? Would my left side go down and right side go up? Yes. So this would actually still potentially maybe be what it looks like. You could even do something like this. Let's see, green, blue, I don't have any other colors. Let me do black. So could it do this? Come up, cross through like the green one did, okay? Come down, bounce off there, and then bounce off like that. Could it do that?
Oh, based on if they're open or closed, right?
What do you mean open or closed?
Like you determine, you go through, either you bounce or you go through based off the domain.
Yeah, so what I'm trying to motivate you to see here is this. Knowing that the left side goes down, the right side goes up is good to know. Knowing the X-intercepts is good to know. But it doesn't give us enough information to nail down exactly what it looks like, right? Because I've just given you like 3 different scenarios that all qualify for this information. It has these X-intercepts and this. So we need to determine whether or not we're actually crossing through. Like, do we actually cross through here at -1? or do we bounce off of it? At 0, do we actually like cross through like the green one did, or bounce off like the black and red one did? Do you understand the language that I'm using there? Bouncing off versus crossing through? And there is a way to do it. It's relatively easy to figure out whether or not it crosses through or bounces. And after our break, that's exactly what we'll do. We're going to talk about what's called the multiplicity. And I think once you see it, you'll be happy. All right? When I put it all together at the end, I promised you wanted this on the test, right? I did, right? So I'm hoping when we bring it all together at the end, you'll be like, yeah, okay, I can do this. All right? Okay, so let's take a 10-minute break. Be back here around 12:21, and we'll figure out which of these it is. right, shall we? Okay. I'm going to pass the sign-in sheet around. Just sign in for today, please. All right, so we were kind of at this point where hopefully I convinced you that we knew a lot, but not quite enough to draw what the graph of this was. And I said that there's kind of an easy way to do it. I actually had the computer graph this polynomial function for us. So of the different scenarios I gave us here, of the red, green, and black, what does the computer say it looks like? The green one, right? It looks like it does what we initially thought it did, and that's that it went through, at -1 it crossed through, then it came back down at 0, it crossed through, and then at 5 it crossed through, right? That's what's happening here. Crossed through at -1, crossed through at 0, came way down here and up, and crossed through at 5. That's what the computer says, right? But how are we going to determine that? Well, the way you do it is as follows. Remember when we were at this step right here, and we set each of these equal to 0 and we got our answers? Okay, our x-intercepts. We said from this one we had x was 0, x was -1, and x was 5, right? Those were our 3 x-intercepts. To determine whether or not we actually cross through or bounce off, you don't look at these numbers. What you do is look at where they came from. This number came from this factor, right? And you look at the power on that factor. So there's a 1 up there, right? Even though it's not written, that's a 1. And see this entire parentheses? That's a 1 out here, isn't it? And then this entire parentheses, there's a 1 out here. You look at those numbers. If the number up there is odd, which they're all odd, right? 1 is an odd number. If this is odd, then what do you think that tells you? If this number is odd, then at this x-intercept, you must cross. This is odd, so at this number you cross. This is odd, so at this number you cross. Now, if it's even, you will bounce. Does that kind of make sense?
Since we're factoring, in what scenario does it become a square?
I'm going to have to give you an example of one that's squared, okay? But I'm just pointing out that this number up here tells you whether or not you cross or you bounce. Odd, you cross. Even, you bounce. All right? Can you take that on faith for right now? Okay? No? All right, so what I'm going to do now is this is the computer's factored form of this, right? We have x plus 1, and x minus 5, right? Same thing. What I'm going to do is I'm going to change this. I'm going to have the computer change this one to a squared. What should happen if I do this x minus 5 and I put squared here? How should our graph change? Let's see. Let's see what happens. I've got to do a few things. Okay, there it is. Still not enough. There it is. There's the graph. Okay, a lot changed, didn't it? Do you see that that's squared now? See that that's squared? So I'm saying if we change this right here to a 2, and now that becomes even, what's happening at 0? Are we still crossing through? Okay, what's happening at -1? Are we still crossing through? Yes, but what's happening at 5? We're bouncing, aren't we? What else has changed in the graph? I mean, because there's some significant changes. Yeah, it's going up instead of down up. The reason it's going up is because when you square this, doesn't that become like a parabola, like x squared? Then you have another x, which would make it x cubed. Then you have another x, which would make it like x to the 4th power. So your degree of your polynomial has now changed from 3 to 4. So you're in a different place on the table now. That quick table to check your left and your end behavior has changed. So there's kind of a lot going on with these, right? Yeah? All right. Let's start one from scratch, because this was all just to get you motivated to think about it, all right? I want to start one from scratch. Let's do this.
Since it's x minus 5, you're squaring it and you're solving for it.
Uh-huh.
I obviously wouldn't write 5 twice. So
That's right, you don't need it twice. Okay, so let's do this. Example here, let's sketch f of x equals x to the 4th minus 9x squared. This is a 4th degree polynomial, right? What is the end behavior? So the first step for this is to find the end behavior. All right? You know what? Let me put the steps over here to sketch. How to sketch a polynomial. Okay, the first step, end behavior. Okay, so the end behavior, what is it going to do? Up, up. Up on the left, up on the right. Degree is 4, that's even. Leading coefficient is 1, that's positive. Everyone's comfortable with that? Okay, second step. The second step to sketch a polynomial function is to find the x-intercepts. All right, so to find the x-intercepts here, we're going to set the function equal to 0, and we're going to try and factor that. So what can you do to factor this? Pull out x squared. That's a GCF first. That will leave you with x squared minus 9. You all agree? If you pull x squared out, you're left with x squared minus 9. Anything else we can do? You have to recognize this as a difference of squares. That's something you look at and you're like, oh yeah, I recognize that. Okay, if you don't recognize that, that's going to cause an issue. And now there's nothing left for you to actually factor. It's completely factored out. At this point, can you tell me bouncing and crossing? Can you tell me at this point? You can. You know that this is even, right? Even. This is odd. And this is odd, right? So you already know right now what's going to happen at each of these x-intercepts. But you have to set these equal to 0. Don't forget, you have to set these equal to 0 at this point. So you set x squared equal to 0. You set x plus 3 equal to 0. And you set x minus 3 equal to 0. So what is the only number that you can square and get 0? 0 itself. So the solution to this is 0. Here's negative 3. And here's positive 3. So we have 3 x-intercepts, don't we? 3 x-intercepts. Remind me again, what are we going to be doing at this x-intercept? Are we going to be crossing or bouncing here? We're going to bounce off here. And here we're going to cross. And here we're going to cross. Does that make sense? Are you sure? The common mistake that I see is that students will look at the number, like they'll say, hey, 3 is odd, so I cross. These numbers have nothing to do with the crossing and the bouncing, nothing. It's the powers on the factors that determine the crossing and the bouncing, all right? Questions now? So I'm going to say the third step, okay, which is kind of like right here, is to determine cross or bounce. And for those of you who may wind up taking 1414 instead of this class, this number right here has a technical name. It's called the multiplicity of the factor. So this factor right here, x plus 3, has a multiplicity of 1, multiplicity of 1, multiplicity of 2. All right, that's just a technical name for it. I'm not going to put it up here for us. All right, so in a 1414 class, usually we put like determine the multiplicity of the factor. But here I'm going to say determine if it crosses or bounces. All right, and then the fourth step is to do your sketch. All right, so really it's not a long process for the polynomials as long as you can factor it. As long as you can factor it and determine the multiplicities, then it's pretty straightforward. All right, so you ready for the sketch? I'm going to squeeze it in right here. Now check out how I do this. There is kind of a process on how you should do the sketch. The first thing you should do in the sketch are put your x-intercepts. Always put your x-intercepts first. So my x-intercepts are at 0, 3, and -3. The next thing you should do is use your end behavior. So what was the end behavior we had? Up, up. So on this picture, my two sides should go up, shouldn't they? So watch how I'm going to do this. I'm not going to start at this point. I'm actually going to start about right here. And I'm going to just go up like this. And then over here to the right a little bit, I'm going to go up like this. All right? Now, I'm going to go back to first grade and I'm going to start connecting dots. But as I connect them, I need to pay attention to what's happening at each of the x-intercepts. So at -3, I'm supposed to cross, right? So what I'm going to do is start drawing this down to -3. I'm going to cross through. All right? And then, without picking up my pencil and maintaining a nice smooth curved graph, I need to get back to 0. Right? I'm going to connect this dot to this dot. When I connect them, when I get to 0, I need to bounce off the x-axis. So I need to do something like that. See how I bounced off? And then I need to connect that dot to this dot at 3, and I need to cross through when I get to this one. So I need to maybe come down and back up like this, cross through, and then connect them together. You see how I did that? That's our picture. We're done. Now I'm going to have the computer graph this for us, and we're going to compare ours to the computer's. What was it? It was 3, -3, 0, and 0. All right. Well, I've got a lot of stuff up there I need to erase. There we go. Okay, so there's the computer's rendition of the graph, and here's ours, right? Now, it looks like it goes up on the left and right. At -3, it crosses through, it comes down, it comes back up, bounces off of 0, comes down, comes up, crosses through 3, and goes on off forever to the right. Ours does that, doesn't it? Now, you might be saying to yourself, well, theirs, comes down to, looks like about -20, right? And it looks the same on both sides when ours doesn't really look like that. So you might be like, well, our graph kind of sucks, which I agree, it's not perfect, all right? It's not perfect. But to actually figure out what these points are, like they're like the highest ones and lowest ones, those points, we could do it for a parabola, couldn't we? We had a formula for it, the Vertex Formula. But in general, with polynomials, just general polynomials, to find these lowest and highest points on the graph requires calculus, all right? It's actually an entire section of the book, an entire chapter of the book in calculus. It's called Finding the Maximum and Minimum Values of Functions. And so here in a college algebra class, we just wave our hands at it and we say, look, all we want to know here is basically where our graph is above the x-axis and where our graph is below. In other words, I can tell you with my picture that between 0 and 3, I get negative values out of the function. Between -3 and 0, I get negative values out of the function. Past 3, I get positive values. Now, I cannot tell you how far down it goes, but it's still something, right? So you'd have to, again, take calculus if you wanted to actually figure out how low those points are. So that graph is completely perfect for a class like this. It's 100%, you get 100% credit for drawing it like this. So everybody's graph is going to look a little different, depending on how far this person decides to go down with this, right? But we should all have the same x-intercepts, the same crossing and bouncing points, and the same end behaviors. All right, we should try another one. Why don't I give you one to try, yeah? Let me just make one up real quick. This one will be interesting to see how y'all handle this. Sketch this. F of x equals x to the 4th plus 6x cubed plus 9x squared. So go ahead. Go through your process. Help each other out if you need to. Raise your hand and ask questions if you need help. How are you doing over here?
I'm just confused. How are they both like negative?
Because there's only, okay, so there's only one answer, right?
Yeah.
-3. So you only have one x-intercept here, -3. And then you have this one, right? So you're supposed to bounce off both of them. And it's supposed to look like this.
Oh, okay, so then it would be like that.
Kind of. More like, you're supposed to go like this and like this, right?
Yeah.
So you have to come here, you have to bounce off,
Oh.
bounce off, come back up. All right. Yeah, you're getting there. That should be a 3 out here instead of an x, because you're pulling a 3 out, right? You're pulling a 3, and then inside x plus 3. There you go. Yeah. Okay, I'm going to work this out up here. Just put the work up here so we have it, at least on video. So it goes up because of the leading coefficient test. The x-intercepts, you set it to 0. You pull a GCF of x squared out. And then this quadratic turns out to be x plus 3 times x plus 3 equals 0. And this, I think, was the tricky part. Okay. I think that's where you are now, right?
Yes.
And just don't forget that x squared out in front, right? Okay, now, normally we would say just set these 3 equal to 0. But see, 2 of them are identical. And since they're identical, we can actually write that like this. X plus 3 times x plus 3. And then you can set this equal to 0. And then all you have to do is set the inside of that equal to 0, and you get x is -3. That's just you doing x plus 3 equals 0. Just move the 3 to the other side, you get this. So you only have 2 x-intercepts. They're at 0 and at -3. But in terms of bouncing and crossing, these both have even powers. And since they're both even powers, you're going to cross it both. So you're going to cross here. I mean, sorry, bounce. Bounce and bounce. And therefore, when I go to draw it, because the left side has to go up and the right side has to go up, I just need to connect these together where I'm going to bounce here and bounce here. So I just kind of, almost like a ball would do. I bounce off, and I come back up. Just avoid, don't draw V's, okay? And how far you come up with this doesn't matter, all right? Okay. I'm going to give you a different one. It's not harder or anything else, but trying to remember the first one we did. Was the one we did towards the beginning of this when we factored it, was it that? Yeah. That was it? Okay, what if I gave you that as the problem? Like I said, graph this. So yeah, half of you would be happy, half of you, what I mean by that, half of your brain would be happy because it's already factored, okay? So you'd be like all happy about that. The only thing is, when it's written like this, you don't have the leading coefficient test. You can't tell the left and right behavior easily, can you? You would have to actually multiply it all back together to figure out what your leading coefficient was. Does that make sense? So if the problem is presented this way, there is a shortcut to get to that leading coefficient. Don't we all know that when I presented this problem, it was x cubed minus 4x squared minus 5x. Was that the problem the way I presented it originally? right? Yes? Okay. So I gave us this, and then we factored it to this, didn't we?
Yes.
Now, if we start here, I said we can multiply it together to get that back to this, so we could do the left and right behavior off of this. But an easier way to do it is just to look at each of the factors. This is like a 1x, right? This is like a 1x, and this is like a 1x, isn't it? What would happen if you multiplied 1x times 1x times 1x? You get 1x cubed, wouldn't you? If you multiply this, this, and this together, you get 1x cubed. And isn't that the same as this? So you don't actually have to multiply them out. If you just pull your x's and multiply them all together, it gives you that first term. Does that make sense? So let me start off with another example, and you'll see what I'm getting at here, hopefully.
Can you also count the multiplicity?
Yeah, see well, I'm not sure what you mean by that. We can see the multiplicities right away. Oh, you mean the multiplicities to get the power? Yes, that just doesn't give you the leading coefficient, though. So let me give you an example here. What if we had this? What if we had x, 2x plus 5, and negative 3x plus 9? What if I asked you to sketch this? All right? If I asked us to sketch this, what we could do is look at this, this, and this right there. If we multiplied those together, right? If we multiplied those together, what would we get? We get negative. So x times 2x times negative 3x would give us negative 6x cubed, wouldn't it? So what would be the left and right hand behavior of this? We did step 1 now. It would go odd, and then negative, right? So that, right? Up, then down. Now the great part about this one is, like I said, it's already factored, right? So now all we have to do is set each factor equal to 0 and determine the bounce and cross. So can you tell me what's going to happen at these x-intercepts? Like what's going to happen at this x-intercept? Bounce or cross? We're going to cross because the power here is 1. What about at this x-intercept? Cross. What about this one? Cross, right? So we know we're crossing at all the x-intercepts. Let's actually find them. So step 2 set x to 0. That's this one. And then we set 2x plus 5 equal to 0. Right? That's the middle factor. So that's 2x equals negative 5. So that's x equals negative 2.5. If I divide both sides by 2. So that's my second x-intercept. And then the last one, negative 3x plus 9 equals 0. That's negative 3x equals negative 9, and then x is 3. Y'all see how that works? Sure? So I can graph it now. Start out with the x-intercepts, which are at 0, 3, negative 2.5. Got a question? What? I need to slow down?
No, I just couldn't read it.
Which one?
I see it.
You got it? Okay. So my left side goes up. My right side goes down. And I'm crossing through every single one of them, right? I just want to have fun there. There we go. Right? There's nothing wrong with me doing that. You could just go like that, right? And we both get the same result, basically.
Can we do that on the test?
Yeah, if you want to draw me a big old, go for it. Go for it. Let's do another one of these. This one's going to be a little tricky. Let's see what you do. So this one is already factored, right? So we're happy about that, but we have to determine the left and right hand behavior, which means we need to use the leading coefficient test. We need to figure out the leading coefficient. Now, I said this was a little tricky. And that's because you've got some bigger numbers up there on those powers, don't you? Okay, so let's see how we're going to do that. This right here is x cubed, right? Okay, so x cubed, I'm going to put that here, times. Now this is just x, right? But you're going to wind up squaring this factor, right? Which means it's going to become x squared. Like just think about that. If you did x plus 2 times itself, the first multiplication you do gives you what? X squared, right? And that's the biggest power you're going to get out of that. If you did the rest of it, it would be, that's what you would get if you multiply that out and put things together. So you get an x squared out of that, don't you? Okay, so this is going to give you x squared. This one is going to give you what? An x cubed, because it's to the third power here. And then the last one is going to give you x to the what? Fourth. So what would you get?